so happy to be here. I'm very honored to be addressing you all this morning, and look forward to sharing ideas and learning a lot about what you've been doing over the last year. I'm also very appreciative to Dr. Hok-Young Shun for bringing me here, inviting me here, and involving me in this, and likewise to everyone, the conference and summit organizers and the ARC NICE Hub folks who helped me out so much and have given me a really warm welcome since I landed here on Saturday. So I get my timing right here. Should I end at 10 or should I shoot for the?
So you have a flexibility. So
Okay,
you can
okay.
add the wherever.
I'll try to not go too much past 10 then.
Yeah.
Maybe go a little past. Okay, great, wonderful. So yeah, I'd like to share some experiences and findings and thoughts with you all from our last 10 or so years of working with urine diversion, and so much of the presentation is about just a mashup of many of the things we've done over the last decade and some of the lessons we've learned from that, and then I end with our take on what three of the most promising avenues are for where urine diversion could be applied in the United States, at least, where it addresses some active practical need that could give it footing to actually be widely adopted. So to give you just a little context, where we are and where we're situated, this is the upper corner of the map there is Vermont. That's where the little pin is. We're the second smallest state in the country by population, and we're just north of Massachusetts and just east of New York State. And this is the town of Brattleboro, and it's a small town, a little over 10,000 people, and we're a rural state, a lot of forests, a lot of farms, and our climate is characterized by warm, humid summers and cold, snowy winters, which has an effect on agriculture and also on how we can do our urine diversion. And our institute is really founded and directed specifically at this same issue. Our vision is a world with abundant clean water and fertile soil, achieved by reclaiming the nutrients from our bodies in a life-sustaining cycle. And we accomplish that, or we strive to accomplish that, by engaging in research, education, and technological innovation to advance the use of human waste as a resource. So a lot of commonality with what you all are engaged in, I think. And we are driven by the same fundamental fact that human waste is less than 1% of wastewater. Wastewater is essentially tap water with a little bit of other stuff polluting it. And our motivation is to grab that human waste before it gets mixed in and use it as a resource. And of course, the fact that urine contains most of the nutrients and about half of the micropollutants makes it a great material to grab out of the wastewater stream to address most of the wastewater treatment sort of requirements in one very small concentrated material, and to aim for resource recovery rather than just water treatment. And in our area, one of perhaps the biggest driver, and the thing that is politically and socially most on people's mind, is water quality. Because our biggest lake, Lake Champlain, is heavily impacted by phosphorus, and then where our biggest river drains into an estuary and into a Long Island Sound is heavily impacted by nitrogen. These dead fish are all from that nitrogen pollution. We founded the Institute back in 2012, and it was a grassroots organization, meaning that we weren't initiated as a program of some larger organization. It was just Kim Nace and I decided we wanted to do something with urine, and so we called ourselves an institute, and we raised $1,000 in seed money to buy some small amount of supplies, and I already knew a farmer who was excited about the idea, and we recruited 60 people that we knew and people they knew to urinate into containers and bring it to Kim's house. And we talked the state into giving us a insignificant waste management approval permit, meaning this is a little thing, you're going to do it once, and it's not too dangerous, so we'll let you do it in this one little spot, this one little time. And that's where we started. And we did it just because we felt like no one was doing it in the States, other than homeowners were doing it, gardeners were doing it, but no one was doing it in public. We wanted to start the conversation. We did that in 2012. This year in 2023, We have about a $500,000 budget, 230 dedicated urine donors who participate around the year, and we collect 12,000 gallons. We collect about 45,000 liters. I wish we didn't use imperial units anymore, but we do. And we are doing a bunch of different research. One thing we do is multi-year field trials looking at soil health with a couple of universities, but you'll see in the presentation other forms of research as well. So it's come a long way in 10 years. It's been a really exciting ride. And one thing that in terms of lessons learned definitely is that this strategy worked. The strategy of just starting by doing it, telling people we were doing it, and just doing the bare minimum to do something on the ground and start that cycle worked. Because now we have this urine nutrient reclamation program. It's the first community scale urine diversion program in the US, and there's a few key factors for what has driven its growth and success, I think. One of them is that the participants, I can't really point on that, it's too bright, but I can point my finger. The participants are geographically scattered. So this is not like a development. We talked a developer into. It's people all over the county who want to be involved. They do this in their homes, in their offices, in their businesses. They can participate inexpensively, and I'll show you why in a minute, how they do it. They choose their own collection method, which is related to that. And we recognize them for their efforts. There's a community around this, and we have a competition every year. We call it the piss off. I don't know if that translates or not. I guess it does. And so people log how many gallons they collect, and we have a trophy for the grand prize winner. We have certificates that go out. People are very proud of this. A press release in the newspaper. It's full on. And people are motivated by different things. Some of them it's water conservation, some it's pollution avoidance, and some it's fertilizer production. And the way that we do this, the logistics of it, is that that people can have, if they do the low budget introductory way, they have just a 20-liter container with a sealed lid and a screw top to a funnel, and I'll have more on that later, that they then drive when it's full. They take the funnel off and put a cap on it. They drive it to a depot and pump it out, or they empty it into a barrel on their property, and then we come with a truck and we empty the depot or the barrel, or they have a permanent porcelain fixture that goes to a storage tank, and then we pump out their storage tank. We bring that to a treatment facility, and then we pasteurize that, and we bring it to the farm and apply it to the farmers. And for collection, we have now 2 of these urine depots, and over 200 donors who bring urine to the depots. We also have about 19 installations of porcelain or others. Some of them are composting toilets, but urine diverting, we pump that out with our truck from the house, so it's very low effort from the homeowners. Then we have urine diverting portable toilets, 17 of those. We rent those out. That's a profit-making part of our service, that we rent it out to events and wherever. And the urinals are connected to a tank, and then the seat is connected to a larger bin, which we then take all those solids for recycling, for composting elsewhere. This is the low-cost collection system we have. It's very low cost. It's very homemade, but it's an introductory way that we've approached it. And we used to really not talk about it because this is sort of like the very do-it-yourself kind of thing, but I'll tell you why we talk about it more now. What it has is it has this 20-liter container, a little sleeve around it if you want that for aesthetics, and then plumbed connections all the way up, watertight connections up to the funnel. This plastic ball goes in the funnel, so that floats up, the urine goes in and settles down. That seals it against odors. And some people also add vinegar to it before they fill it to inhibit urease and keep the nitrogen in the urea form instead of the ammonia form, which eliminates the last remaining faint odor from it. And women can use a P-style is one thing we offer is for standing to urinate, or the nun's cap or the hat from hospitals that fits under the seat, and then they pour that in. And then when it's full, they detach the funnel, put on a cap, and this is a vacuum pump out station. That photograph is of the actual unit. You put your jug in the unit, you pull down the handle, the wand goes in there, it activates the vacuum turbine, it evacuates the vacuum chamber, it sucks all the urine up, and then the turbine turns off and it dumps the urine into the container, and there's a series of them interconnected, and then we can pump that out with the truck. And we actually really promote this jug system now. It lets people try it out. It lets people have no commitment. They just pay about $50 for the system. They can take it home, try it out, get excited about collecting their own urine. They can even use it in their home garden while they've got it. And then some of them graduate to a plumbed system. because it is work to take that jug. You get tired of it eventually, but it's a way you can say, well, I'll try this weird idea, and then once you're doing it and it's like, oh, this isn't so hard, this isn't bad, I like this, then you can graduate to a plumbed fixture. We do a couple of Ostmans, the dry and the flush. We also have one of the Laufin Save toilets with the hidden teapot effect urine catchment that probably you're familiar with, but we have one in our office that we're quite happy with. And then this is the pump out. We come with our truck and hook a hose to a port on the side of the house, evacuate the urine, and take it on our truck that takes 4,000 liters at a time. We built that vacuum system on the front, and then we have a flatbed truck. We can just have as many tanks as we need to in there. And then we pasteurize it. And this is where our spin-off comes in. We built a few pasteurizers at the Institute over the years, just in order to manage our own urine treatment needs. But our spin-off came out in 2019. It's called Brightwater Tools, and we're building equipment for on-site urine processing and fertilizer production. And the first thing we're offering now is this pasteurizer. We've sold 6 of them now, and it pasteurizes urine at 8 degrees Celsius for about 1.5 minutes. That meets a US EPA standard for sewage sludge, so it is far above and beyond what urine actually needs. But it means regulators are happy with it because they say, oh, it checks that box. We've already approved that system for much dirtier material, so you can pasteurize and use it. That becomes a Class A material that we can then distribute without really any further regulation or restriction of use. So it can go to home gardeners, it can go to farms, it can go to wherever it needs to go. And so Brightwater manufactures those and sell them. That green building is where Richard Institute and Brightwater both exist, and those are just some of our urine tanks there on the bottom. We store all of our urine above ground and outside, and even in the winter that's fine, because as we'll get to in a later slide, when urine freezes, it doesn't freeze like pure water and break a container. It freezes and begins to form a sort of a matrix of ice with brine in it, and so the brine can always scoot to the top, and it doesn't exert any pressure on the walls. So that was a nice thing, not to worry about the cold. Then we apply it. We take it to farms and supply it to farmers. We sell it to some farmers. That's been a new thing, but originally we were just giving it to farmers in exchange for them participating in our research and helping us in our work. So this is a tractor-drawn applicator. That is a 2,000-liter applicator, and it's being used on perennial grass here for hay or for pasture. And that can certainly scale up, but that's the scale that we're doing it on now. And it comes out in those streams onto the ground so that it's not a spray. It goes down, because we don't process the urine into another form. This is just pasteurized urine, so it's very high in ammonia. We also have used it on sweet corn, which is a sweet variety of maize that we boil up and eat fresh. That farmer is very proudly showing it off. He's very proud to be using urine fertilizer. And what we're doing on here, you can probably barely see, is here's a tank on the back. There's a hose running in, and there's a cultivator tines here. So it's turning the soil to kill the weeds, and the urine gets poured down onto the ground and then immediately buried. So the ammonia doesn't volatilize because it's buried under the soil. And so we've been trying that, and then also a method for getting into the soil is drip irrigation. And ABOG did an early project years ago on that, and so we thought we'd give it a try. A little bit of concern that the minerals in the urine would form deposits in the drip irrigation emitters, but it didn't with medium hard water. With very hard water it did, and we're working on ways of pulsing the urine so that it doesn't mix as much with water. But for most water, it's fine. And we grew hemp, or we supplied it to a hemp grower, and they saw a 6% increase in the CBD content of the hemp, and then a 32% increase in this particular chemical, the CBDV, which they were happy about. And then we also, at our research center, have an anthrovermoponics setup. So there's a worm composting tower where a lot of potassium and phosphorus and other elements come out of that food waste that gets directed into the vermoponics, or the hydroponic system. And then the urine supplies some of those materials, some of those elements, and then all the nitrogen. And I'm very curious about actually the life cycle impacts of this kind of growing, but we haven't analyzed that yet. But it is a wonderful showcase, and people really engage with it. They walk in the door, they see this wall of green lettuce and other plants, and they can eat it, they can taste it, and say, oh, that's delicious, it's fresh. This does not taste like pee. And that's, I think, another lesson we've learned is that when people see it, they like it. When they just think about it, they're not as sure about it. So being able to demonstrate like this is a nice thing has been very valuable. We've also had a lot of education about regulations, because when we started, we had a pretty informal process. We got a permit for treating and applying the urine, and originally we treated the urine just through time storage, 20 degrees Celsius for 1 month before we applied it on the grassland, and so we only had that permit. We didn't look into or pursue plumbing permitting or wastewater permitting because we weren't really squarely in any of those permit fields. But over the years, the regulators have heard about us and sort of pulled us into their regulatory spheres. Fortunately, we've had time to do that. Didn't have to do it all at the beginning. Plumbing is a place we've made some inroads. The IAPMO, the International Association of Plumbing and Mechanical Officials, I believe, they produced the UPC plumbing code. I'm not sure what you use in Australia, but we were invited to work on a urine diversion and composting toilet supplement to that, which we did, and that has been useful in the U.S. and I think it's available around the world. It's also an ANSI standard, so it can be used as a supplemental standard, even where the UPC isn't used. So that's been helpful, and we ended up working with the state of Vermont. And I always laugh at this. This is an engineered drawing of someone emptying a jug into a barrel, but it has all this particular information about it, and it's approved as an innovative alternative system for wastewater treatment. And it was a whole pain to get it approved, but now it's something that anyone in the state of Vermont can do this. It costs $1,000 to do all the legwork to get the permit, which is a big barrier, and we're working on that. But it's now legal for people to collect that jug and with a special spout that doesn't splash, empty it into a barrel and we pump it out. Also for the plumbed system, that's also permitted. And we're sharing these drawings with anyone in the U.S. or of course if there's any use here, we'd be happy to share it for showing to regulators and saying here's an approved system in another jurisdiction, and here are the aspects that go into it. We also have a whole branch of our program that's social research, and a big part of that is farmer engagement, working with farmers. It sort of all started when I met a farmer I'd worked for before. I met him at the hardware store, and I was talking about this idea of urine diversion. He said, "Oh, I'd love to do that because I'm organic. I'd like the nitrogen." So we've always been going back and talking to farmers, and part of the underlying principle of our whole program, the whole urine recycling program, is that we're doing it. We were doing it from day one. We were doing it as a full cycle, so collecting all the way to application and growth of agricultural products, because we figured we would find out where the problems were that way at the beginning rather than down the road. And so part of what that process means is working with farmers who say, well, it takes a long time for the gravity feed to empty this applicator, so we're working on a pump system to make that go faster. And then questions about, well, the ammonia volatilization. This is a manure pit, and the manure, the dairy manure, is similar. It's got a lot more phosphorus compared to nitrogen than urine has, but the nitrogen evaporates. They've got that same issue. So I'll get to that later. But we're driven by farmer needs in terms of our ag research, and then we do a lot of stakeholder engagement in terms of interviews and dialogue groups for the public at large and for farmers, because sitting people down and talking with them, we get a sense of what people's, just off the street, what their concerns are, what interests them about urine diversion. That helps us direct our research to be applicable to what people will actually in society, how they'll receive it, and helps us work toward a future where the tools we develop or the strategies we recommend are supporting people and including people, rather than perhaps being extra burdens on people in terms of cost for housing, and maybe people who are least able to afford it are then impacted by something we want it to be a green intervention. And then the thing that I am most, I always just come back to and most impressed by and surprised by is that whenever we've talked to people, the whole time we've been doing this work, they always, when we explain, here's why we want to do urine diversion, here's why it's great, they say, well, that sounds great. I think it's great, but no one is going to be ready for that. The world's not ready for that. You know, the next person you talk to is not going to think that's so great. You talk to the next person, they say the same thing. And so that's an ascribed attitude. It's an attitude that people think other people are going to have, but it's not the attitude they necessarily have. So getting folks together to talk and realize that, oh, no, actually, we all think this is kind of interesting. Not everyone thinks it's great, but it's surprising how many folks do. And that is a takeaway that has really given me a lot of confidence in talking about it and thinking it can be adopted, and also has changed the way I message, because we never apologize for what we're doing. We never like say, oh, this might be kind of gross, but I don't think you all do either. But that's been something we learned, and at the beginning I was very nervous and hesitant about, and have become much more confident. One thing people are concerned about or have questions about are pharmaceuticals. And are there medicine residuals in my pee? What happens to that? Will it end up in the food? So our first academic research project was teaming up with the University of Michigan, who had National Science Foundation funding to do pharmaceutical testing. So we did all the field trials. We grew corn. No, we didn't. We grew lettuce and carrots for 3 different years, and collected samples of plant tissue, of the soil, of the groundwater, and lysimeters below it. And we used urine we collected. We also collected urine that we spiked to the highest reasonable level you would expect in a community collection system of over a dozen different pharmaceuticals from different pharmaceutical groups. What we found were detectable but very small levels of several common pharmaceuticals or drugs in plant tissue and in the soil and the water, but the levels were quite small. To get 1 cup of caffeine worth of coffee, you'd have to eat a pound of lettuce every day for 2,000 years. So very small amounts, vanishingly small amounts. To get 1 tablet of paracetamol, you'd have to eat 150,000 carrots. In one sitting. That's a lot. So our takeaway from that was that it wasn't really a big exposure pathway for pharmaceuticals. And we don't currently remove pharmaceuticals from our urine. We explain this to our farmers. They say, well, that seems reasonable. But it's a kind of a long explanation. It took me a couple minutes to explain it, and for you all to like hear that and accept that as a sufficient explanation, you have to kind of have a trust in numbers or in concepts of concentration, relative concentration, and concentration being an important factor. And there's some people that that's not what they just hear, oh, you detected pharmaceuticals in this food. I'm not sure how I feel about that, which is why a lesson we learned from that is we still want to remove pharmaceuticals, even though we don't think it's necessarily truly necessary. It's not necessarily necessary, but it is necessary from a perspective of just public understanding to be able to say there are very small levels, tiny levels, and then we do a step that removes X percent, 90% of pharmaceuticals. That's sort of a belt and suspenders approach, and it feels a lot more solid in terms of just getting everyone on board. Another thing we learned, from our farmers was that the ammonia volatilization is a concern. It's a consideration, and we did some testing and found there is some level of volatilization. We might lose. It's hard quite to quantify, but it might be 10 or 15% of the ammonia being lost to evaporation, depending on the soil moisture levels. And so we've been working on bioacidification, and that is using a carbon-rich waste material, or it doesn't have to be waste, but for us it is, to mix with the urine or other liquid manure, in this case urine, and that carbon-rich material ferments to produce lactic acid or other organic acids that lowers the pH of the urine, and the low pH converts ammonia into ammonium, which is not volatile. And in order to try to do this in a circular economy sort of way, we used 2 materials that currently have disposal challenges in our area: whey from cheese making or yogurt making, and short paper fibers from paper processing. Both contain high amounts of organic carbon. And we made different recipes of those and mixed them with urine in different proportions. The red line is the control, and then the other ones are all the recipes. So the x-axis is time. It was a 100-day trial in little 50 milliliter tubes, and the pH is on the Y scale. And you can see that the urine as a control stayed in the 9-8 range, and then the different recipes all dropped to different degrees. And some of them dropped very low, some almost reached 4, and others were a more moderate decline. But it definitely was effective, and other slides kind of discuss the different versions there. One thing I want to point out is that that the warm treatments work better for some recipes, and the cold ones work better for others. And at the higher levels of whey addition, the warm levels let it, I think, digest further and faster and go more acidic. But at the lower levels, the cold condition worked better, potentially because it may have inhibited microbes that would have just consumed that carbon substrate and not made acid, but made something else, made methane perhaps. And so at the cooler temperatures, it actually dropped further at the lower whey proportions. And we also tried cultured and uncultured, so we added a bunch of bacteria and microbes too to some of it, and that was definitely helpful with urine. Then we simulated land applications. So we had these jars where we put a little beaker of the fermented urine, and then another little glass of boric acid solution to trap any ammonia that evaporated, that volatilized, and then a little CO2 trap as well. And after certain periods of time, certain numbers of days, we would test the traps, titrate them to determine how much ammonia had been captured. And what we found was these are four recipes for the urine that are most revealing, I guess. And the red one is the control. So we had about 8 grams per liter of nitrogen in the urine, and in the control, over a few days, say over 5 days, in these bottles, we lost over 4 grams of nitrogen. We lost more than half the nitrogen to volatilization. So if we'd applied it in the field, it'd been dry, no rain for a few days, we would have lost a lot. And then the two upper green and blue lines are 6%, 6.25% sweet whey or acid whey by mass added to the urine, and those both had significant reduction. The 12.5% acid whey cut volatilization by more than 50%, and then the 100% acid whey, so the equal parts of whey and urine, dropped it to almost nothing. It's a lot of whey to add, but there is some literature suggesting that lactic acid bacteria can be a biostimulant, can be something that encourages plant growth or improves plant health. So our next step is to look at whether we perhaps could be making not only a fertilizer here, but also a biostimulant. Okay, gotta keep moving here. So another area we've been working on is concentration of the urine, because it takes a lot of space to store urine. We do a lot of short hauling, so we collect it within a few miles and take it a few miles to farms, so it's actually reasonable to move it unconcentrated. But if we were taking it longer distances or needing to store larger volumes, it would become impractical and energy intensive. And in order to make this actually a positive environmental intervention, where it is using fewer resources than conventional wastewater treatment and fertilizer production, we want to do this in a concentrated way so we can distribute it without the transport costs being exorbitant. And we are working on freeze concentration because it can concentrate urine effectively. It's less prone to fouling than reverse osmosis, and it consumes less energy than distillation, because the heat of fusion, of freezing water, is about 1/7, I believe, the amount of the heat of vaporizing the water. So that phase transition, freezing, takes a lot less energy than distilling. But then the trick is energy recovery, which there's methods for in both approaches. Well, just a moment to talk about the hows and the whys. When you freeze a solution, any solution, the ice that forms, like I was saying before, is pure water ice. It's a pure water crystal, and all of the solutes remain in the liquid. It's unfrozen, and so if we partially freeze urine into ice, say 75% ice, then 25% of the liquid is left containing all of the solutes. We can drain that and have a concentrate, and then drain the ice and have our effluent. And it's physically simple. It's very resistant to fouling. And the energy recovery process is that this part is it's two chambers. This part's freezing. This part is thawing. And our heat pump is taking heat out of the freezing side and dumping it into the thawing side. So there's a very small temperature differential. And this is just sort of a crude schematic of that. Here's the freezing part. There's the thawing part. And this just symbolizes the heat pump with energy coming in terms of electricity, and then much more energy being moved through in the form of heat, because there's a high coefficient of performance, because there's a very small temperature differential between the two sides, only about a 12-degree temperature differential between the two thermal transfer surfaces. And so we did several, more than several, we did a lot of trials on this with a 10-bottle setup, getting all the different fractions that came out, and found excellent partitioning. So these are, each column is a bottle, and the first two columns had the vast majority of the nutrients, and we went from up to over 50 grams per liter of nitrogen, which is about a 6x concentration. This is after a couple stages of the process. And then we had a little middle range that we recycle back into process again, and then our reject water is sort of like our effluent has less than 10% of the nutrients in it, and we can dial it in to be more or less depending on how where we put those cutoff points. But it's quite effective, and in terms of energy usage, it all comes down to the temperature differences that we have between the two sides. So this is the ideal maximum coefficient of performance versus the temperature lift, and we had between 10 and 15 degrees of lift. So theoretically, we could be having a coefficient of performance in excess of 20. Now, in reality, refrigeration is only maybe 50% efficient, and there's other losses in the system, but there's potential for a coefficient of performance of much higher than Unity. And so we're optimistic that with further development, which Brightwater Tools is doing, we'll get an energy efficient system that can probably use more energy than RO, but not much, and hopefully use a lot less than distillation. So to wrap it up, I want to talk about the places we see a lot of potential for urine diversion to have a positive impact and be adoptable for reasons other than just thinking it's a good idea. So actual practical considerations. And for septic systems in the United States, and I'm sure other places as well, there can be a big issue of essentially nutrient injection into the groundwater, where nitrogen goes right through the system, goes through the drain field into the groundwater, and then ends up in surface water, and that is nitrogen pollution in downstream. Phosphorus can come through there too, depending on the soils. And this is a big issue in Cape Cod. So there's the United States again with Massachusetts in red. That's the state just south of us. And there's a blow-up of Massachusetts, and the Cape, that arm coming out there, has a town of Falmouth where there's a real hotbed for trying to do something about this, because they have a problem. They've been told by the EPA, ordered by the EPA, to reduce their nitrogen emissions very significantly, and if they do it by sewering, it's going to be between $50,000 and $100,000 cost per house connected, which will be borne by the town in general and by the homeowners, and it's an incredible cost, and it will make housing unaffordable for people who are having trouble affording housing already, and so that's a serious problem. And the build out is over decades. It will be maybe 40 years before all that can be built. So there's a Pond Coalition environmental group. There's a grassroots group of folks who are promoting urine diversion, who bought a bunch of these jugs and funnels from us, and there's the Massachusetts Alternative Septic Test Site Center, which is a government body, and they do testing of nutrient removal systems on in an in-ground test system. They are very excited about this, and they're providing the technical support and the credibility for it. And this is launching as a sort of its own little grassroots initiative, because they have this crisis, this affordability crisis and this pollution crisis. And you can see all these red dots are coastal ponds or little estuaries that are in unacceptable condition. And then everything except for these little light yellow colors are out of equilibrium in terms of the nitrogen flux. So there's more nitrogen going in than can be safely handled by the ecosystem all throughout the Cape. And so we sent down a whole raft of these down to Cape Cod. There's over 30 people now using these jugs, and they're working on the next steps. And then this just came out a couple of days ago, and I just want to read this part. The State Department of Environmental Protection has recommended that rather than doing a urine diverting pilot program, the town of Falmouth should skip the pilot and instead apply for provisional use for urine diversion. If the town chooses to proceed with this application, it will take years off the process of getting general use approval. So this is kind of shocking to me, is that someone somewhere in the regulation and the government is saying, let's actually do this, which is new. This is 10 years the Green Center has been pushing for this, and now it's finally getting a little bit of traction. So that's extremely encouraging. Then another use case is just direct use of urine on site or right nearby to meet fertilizer needs. And this project has nothing to do with us. We just admire it very much. It's in Niger, and it's this federation of farmers who are collecting urine and using it to increase yields and to support their health of their families by being able to better grow their own food using urine, which they have renamed. They call it Oga, which means boss. It's the boss. It's like a powerful thing, and they don't want to call it urine because they don't like urine, but they don't mind having the boss help them out in the fields. So that's kind of their own idea for their own rebranding, and they've got 3,000 farmers doing that. In our area, we run an education program, and we've gotten some grant funding to do that, to just do outreach to people who want to use urine in their own gardens, and we just share information for them on how to do that. And one way is using their own things you can get locally, or just make out of stuff everyone can get. Then there's also the pea cycling kit that we offer. People can buy it online. We have an Etsy store, and they can just go and order it. We ship it to them. And then there's these more expensive but nicer, more established units they can buy to collect urine at home. And then we have recommendations based on the World Health Organization's recommendations on how to deal with health and how to protect health and deal with sanitization. And for direct use of urine, that is just urine where you urinate it into a container and you're going to use it, that we recommend you wash your hands after you apply it, and you wait a month before eating raw food. But that's it, because it doesn't have the fecal contamination. And then if it's a larger project, or if it's a urine diverting toilet, then there's the storage that the World Health Organization recommends, and then also pasteurization as an option. We can supply pasteurizers to projects, which we've been doing. And some of the projects we've been doing are the Cape Cod or other organizations that want to have pasteurization and do it as a permanent larger project. And then we encourage people, since the nutrients in the urine are so soluble, that they are careful when and how much to apply. So don't apply it all at once, and apply it when the plants need nitrogen, between the seedling and the flowering stage, when the nitrogen uptake is the highest. To do it on plants that need the nitrogen, and wash your hands after you apply it. Put the urine on the ground. Don't spray it in the air or spray it all over the plants, and get it safely into the soil, because it has that volatile ammonia. And so we recommend that we have the order here, right? One is bury it under a furrow, one is irrigate it as you go, or put it in the rain, or one is dilute the urine so it just carries itself down in the diluted water. And then the final avenue that we're really excited about is building scale nutrient recycling and water paired with water reuse. So this is another Brightwater Tools slide and product. The big red box encloses all of the different parts that we're working on to sell as a package. So I'll just actually talk about the flow here before I talk about the parts. So waterless urinals go in, directly drain with acidification or not, and that's a whole other thing that I won't get into. And vacuum flush toilets can also go to an anaerobic digester first, and then into the high strength wastewater tank. And then the freeze concentrator, it doesn't care if there's ammonia or nitrate or urea. All of those are concentratable, so there's no issues with ammonia loss like there is in RO or in distillation. So any of those forms are fine. It's pretty resilient there. Freeze concentration happens, then pasteurization happens, and then charcoal filtration. Although I'm actually pretty excited about the work with the MBRs and the powdered activated carbon that you all have been doing here. So that may down the road enter more into our planning as well. But for now, this is what we're envisioning, and so that produces a concentrated and sanitized fertilizer, and then a low strength effluent that can go out and combine with gray water from the building. And so the goal here, or the highest vision for how we think this could be used on site, is that all the gray water from the building, you can see on the right, the sink and the shower and whatnot, plus this effluent from the concentrator, are all low in, there's a very low nutrient load in all that. It could be treated and reused on site as reuse water, and then there's no effluent from the building. It doesn't have to be. It can be totally enclosed. Doesn't have to have a sewer connection. And in the United States, in some cities, it's a very high connection to the sewer because the sewers are overburdened, or they have issues that make taking new customers difficult and expensive. So you have to pay a lot to connect. And so there's this avenue to saving hundreds of thousands of dollars on the sewer connection fee by having a system that doesn't require a sewer connection. And so that's a place I think this could have a lot of value. Also in situations where it's discharged to the ground, it's discharged through a drain field, and there are nutrient limits, phosphorus or nitrogen, that just keeping those nutrients out of the gray water stream would let that gray water either be discharged directly or reused and eventually discharged. But take the nutrients out as a product rather than having to treat the water to try to eliminate them one by one in a non-usable form, get them concentrated form so they can become a product. And that product can have some value. We currently we're confident that product has a dollar value, but we don't really know what it is. There's a lot of estimates we've heard from different people all over the place. So we're really concentrating on the value as it's the wastewater treatment. We can quantify that better, and that's more the value proposition as a startup to our potential customers, our investors, is it handles wastewater better and it has the benefit of making a green product. But we don't really know what the economic value will be of that product. But I know that you all are working on that, so we're excited to hear what you learn about that as well. And then a closing thought that does definitely guide how we've approached this system, and what we focus on energy all the time, and on the physical material required to build the system, because my biggest concern is I don't want to chase this ideal of recycling resources out of human waste and throw all kinds of technology at it that take energy and consume resources to make a fertilizer that actually is worse for the planet because it took all those steps and all those resources to get there than just doing it the conventional way. So one thing that I'm really eager to do, and haven't got the funding yet, but we keep pursuing it, is a life cycle analysis on at least a couple of versions of this sort of urine recycling, whether it's this one or one of the more simple ones, so we could start to be more confident. And there have been some. Stephen Hilton and others did a LCA a few years ago on urine diversion, but they didn't consider the infrastructure costs or infrastructure resources. And so I'd love to see that. And I guess that's the thing I really am curious to talk about with everyone I meet here, and as your research goes forward, is really understanding what resources are used and quantifying the value. And I think there may be some niches where the value goes beyond the calculus of energy saved on wastewater treatment and energy saved on fertilizer production. And there's other factors too, like there's all the resource extraction and all that. But the energy is what often I think it comes down to in conversation, is you save energy on both sides. But in some cases, like in Cape Cod with that sewer installation project, there's a huge amount of energy and expense in digging and in plastic pipes and the management of that sewer, and in economic cost. And I think that there may be sort of sheltered niches where there are factors at play beyond sort of the generic urine collection treatment factors that apply anywhere that make it more appropriate there. Kind of like with solar panels, it was putting them on satellites was the niche that they were, I think, originally made for. And then it was, off the grid places that couldn't get power. And now we have it everywhere because it has been refined. But for early adoption, that's what we're looking for, is where are these niches? And I'd be really excited to hear if anyone has ideas about niches in Australia or elsewhere where this makes sense for ideas beyond the more generic theoretical reasons for urine diversion. So that is my my presentation. We're at 10 o'clock, so I don't know how the organizers want to run this, if there's time for questions or if you want to move on at this point.
Any questions? Yes, please, Hadi, first.
Thank you very much. It's very, very fascinating.
Thank you.
Because you explained in simple words, I understood, I think, very well based on your talk. Question is related to human. You are using drugs. Sometimes can be concentrated, especially for the contraception pills and other things. Even for recycled water, they can detect. But how about using cows' urine or sheep, especially urine, in a large scale? Is it possible to use more cow's urine instead of human?
Mm-hmm. Yeah, so that question was, is it possible to use animal urine, like cow or sheep urine, as fertilizer? And it certainly is, and that's more practiced already because farms, well, not all farms, I guess a confined feeding operation where they bring in the grain, they just have to dispose of all of that. But in the farms in our area, they recycle that manure back onto the field. So that's more, I think, of a common practice, and absolutely works in this perspective.
Okay, Stefan.
Yeah, brilliant talk. Thank you so much. I just wanted to mention two things that we think might be a concern, but you haven't mentioned in your talk, so I'm wondering if you have looked into it. First is sodium. A lot of plants don't like that, and soils like it even less. Have you looked at what happens over time to the soils and whether you need to do something about it? And the second one is antimicrobial resistance. Although the paracetamol and the likes are not really getting into the carrot, could it be that bacteria that are exposed to antibiotics either during the storage of urine or in the soils over time lead to the development of antimicrobial resistance, which could then come back to us through the vegetable we consume?
Right, yeah, thank you. So the first one about salt, we have a very different climate, like I mentioned. So our precipitation far exceeds evaporation. And so we don't have buildup of salt in the outdoor, like in the exposed soils anywhere in the state of Vermont, because it's just constantly flushed through by the rain. So so that's a question that is not a concern of ours, but definitely has, it comes up in more arid locations. I don't know what it's like here in Sydney. I don't know how that balance is if you have salinity in this area, but I know that it's definitely an issue elsewhere in the continent. And the one brief, it was just really a back of the envelope calculations I did, so it's more just an idea of something to look at than a finding, is that that compared to irrigation water in irrigated land, the amount of salt added by irrigation was much higher generally, just from the salt in groundwater, than what was in the urine. And then what I wanted to pursue more, but I actually haven't, just because it's not pressing in our area, but is looking at synthetic fertilizers and what levels of salts are in those, because I know that is an issue as well. But no, I don't have any concrete answers for that. But I do believe that and this is more just an impression than anything else, but I think that there are a lot of things that add salt to farmland, and that urine is not, I don't believe that it is like vastly more than other factors, but that's actually, maybe I should have even said that. I'm not certain more of that than just like trying to skim through things and get an idea, because I just haven't focused on it. And then in terms of the antibiotic resistance, that is something that our partners at University of Michigan were looking into. I also know that there's been some more recent more recent research on that, and our partners in Michigan, they had encouraging results that did not look like many of those were able to carry through. But I don't remember the details of that, and I would recommend, if you wanted to look at that, Nancy Love is the author on all of those papers, and it's through University of Michigan. And if you look for antibiotic resistance genes urine and her name, I'm sure that you'd find the ones that I'm not remembering very well. But yeah, that's definitely on other people's minds, and I don't have a great answer for you.
Cara?
Thanks, Abraham. That's a really interesting talk. In comment with the cows and the sheep
Yeah.
urine, I'd like to see a cow try and go in one of those toilets. That'd be utterly crazy. No. So I was really interested. A lot of the success, and particularly it would have been really satisfying getting that news item through very recently about Cape Cod.
Yes.
There's a lot of reliance on human behaviour and humans doing it right, collecting it right, using it right, treating it right, and so on. Have you had any regulatory pushback from that, or I could just imagine here in Australia, I just can't see them letting that go through. But yeah, I'd be really interested in your thoughts on that.
Did you mean in terms of like the jugs?
Yeah.
Right.
So kind of selling or letting individual households go and collect the jugs and so on, and then handling it themselves and having a little sign saying, well, just wait a month before you eat anything that you might have popped your wee on. And there is, I guess, some chance of cross contamination, fecal contamination. Or there's always some risk. It's never ever sterile.
Nothing's ever zero, right?
So I was just wondering how you kind of
Yeah.
relied on, or your sense of your confidence that humans are doing it right, because often they're the ones relying on them to do the right thing can be a bit.
Right. Yeah. That's a great question, and I guess the critical aspect there is that for the plum systems and the permitted ones, those we had to convince regulators that you should allow us to do this. But on the other side, at some point, no one is regulating people who walk outside on their land and urinate onto the ground. And at what point does that become regulated? And our regulators in Vermont said, one of them basically said, one of the wastewater regulators said, I don't want to be regulating people with 5-gallon jugs of urine. Like, that's not a thing that I want to hear about or talk about or be regulating. I'll regulate the larger tanks. And what you do else, otherwise, that's not, I'm not looking at that. And then the person who does residuals management, he said, well, people are using their own urine on their own land. That's not a residual from a wastewater treatment process, so that's not my job either. So basically, the people who oversee it said that's not my job, and so it's not regulated. Someone may come down at some point and say that is mine and I do want to regulate it, but that's why, as far as we can tell, it's legal because it isn't illegal. And in terms of how I feel about people using it, I think that there's a lot of more dangerous things we do than use urine as fertilizer, like we drive cars, and we make choices about what food we put in our bodies, and all kinds of things that affect our health directly, whether or not we exercise. And so if people are using their own urine in their own garden, it seems like a thing they're doing within their household. Thoughts? Yeah.
So due to time, okay, last.
Thank you, Sean, because Stefano stole my questions. Very interested in your talk. I'm responsible for the health risk modelling, so I'm really keen to connect with people in Michigan.
Great.
And I'm already working with the Michigan State Uni on this, so it would be interesting. My question is, when you have people donating, do you give any advice around people who are sick and maybe with UTIs, that sort of thing, not donating at that point? You know, do you give advice around nothing?
No.
You're just relying on the pasteurization
Exactly.
step, which doesn't kill a lot of viruses, but we can talk about that.
Well, let's talk about that later. The state of Vermont thinks it does, and the EPA does. So I'm very curious to hear.
We're learning more about viruses now.
Okay, great. Well, I'd like to hear more about that. But yeah, the idea with the pasteurization is that it's accepted as treatment of wastewater in general, and that includes wastewater with a significant fecal component. So, so an E. coli is huge in feces. So,
Oh, yeah, E. coli bacteria, that's easy.
yeah. So with urinary tract infections, no, we don't have any recommendation on that because the treatment process is supposed to handle that.
Okay, thank you for your wonderful presentation, Avi. Thank you.